The day begins with an unsettling quiet. The air grows heavy, birds fall silent, and a strange greenish-yellow light fills the sky. On the horizon, the sky darkens to a bruised purple as a vast menacing cloud churns and boils. From its belly, a thin ghostly finger descends, twisting and writhing, testing the air below. Nature holds its breath, a prelude to violence. The funnel widens and darkens, becoming a living column of energy connecting sky and earth. As it touches down, a cloud of dust and debris explodes at its base, and a low rumble becomes a deafening roar. The tornado is unleashed, moving with terrifying, unpredictable grace. Trees snap, houses are torn apart, and cars are tossed like toys. The raw force is almost impossible to comprehend, a spectacle of atmospheric power that reminds us of our fragility. In its wake, the tornado leaves a scar of devastation: splintered wood, twisted metal, and scattered belongings. Yet, amidst the chaos, there's a strange, terrible beauty, a humbling sight of our planet's atmosphere at its most dramatic. It's a stark reminder of the forces that shape our world. The fury of the sky is both awe-inspiring and humbling. So, what is this force of nature? A tornado is a rapidly rotating column of air, in contact with both the ground and a powerful storm cloud above. Think of it as a spinning top made of wind connecting earth and sky. Tornadoes can be brief and small, or massive giants traveling for miles. The visible funnel is made of water droplets, dust and debris pulled into the vortex. Winds inside can exceed 300 miles per hour, faster than any racing car. This intense rotation gives tornadoes their destructive power. Tornadoes come in many shapes: thin ropes, wide wedges, or boiling black clouds, but all share the same core: a violent spinning column of air. Tornadoes are born from the most powerful thunderstorms, called supercells. These parent storms are rotating giants, and the tornado is their most intense expression. To understand tornadoes, we must first look to the sky and the conditions that create them. The story of a tornado begins quietly, with a meeting of air masses in the atmosphere. Warm, moist air from the Gulf of Mexico flows north, light and full of energy, eager to rise. From the Rockies or the north, cold, dry air arrives, heavy and dense, sinking toward the ground. When these two forces meet, the cold air wedges beneath the warm, forcing it upward rapidly. This is the first step in creating a powerful thunderstorm. As the warm air rises, it cools, and moisture condenses into water droplets and ice crystals, releasing heat. This heat makes the air rise even faster, creating a powerful updraft. Towering cumulonimbus clouds form, sometimes reaching over 10 miles high. These clouds churn with energy, rising and falling air, rain, and hail. Here, in this volatile environment, the stage is set for the next crucial element. The ingredients are present. Now, all that's needed is a twist. The birth of a tornado is about to begin. A powerful thunderstorm alone isn't enough. A tornado needs rotation, and that comes from wind shear. Wind shear is a change in wind speed or direction with height. Imagine gentle winds at the ground, but much faster winds higher up, blowing from a different direction. This creates a horizontal tube of spinning air, rolling invisibly along the landscape. The storm's updraft tilts this tube upright, turning horizontal spin into vertical rotation. Now, the storm's core begins to rotate. A mesocyclone is born. This rotating updraft can be miles wide, the engine of the tornado. Not every mesocyclone produces a tornado, but every strong tornado comes from one. The storm has become a supercell, a rotating giant with the potential for nature's most focused fury. The stage is set for the tornado's birth. The supercell is the king of storms, a self-sustaining, highly organized weather machine. Its persistent, rotating updraft, the mesocyclone, separates updraft from downdraft, allowing the storm to feed on warm, moist air for hours. This makes the supercell capable of producing tornadoes, giant hail, and destructive winds. Visually, it's breathtaking, a rotating, layered cloud structure, often with a distinct wall cloud beneath. The wall cloud is where the strongest rotation is found, and where tornadoes, most often, descend. From a safe distance, a supercell looks like a spinning spaceship, order emerging from chaos. It's a factory for severe weather, with the tornado as its most feared product. The atmosphere has organized itself into a rotating powerhouse. Inside the supercell, the mesocyclone tightens and intensifies, the wall cloud may descend, and a visible funnel forms as spinning air cools and condenses moisture. At first, it's just a funnel cloud, not yet a tornado. It must touch the ground. Sometimes it twists in the air for minutes or retreats back into the clouds. The critical moment is touchdown when the rotating column reaches the ground, often signaled by a swirl of dust and debris. The tornado is born, its destructive power unleashed. It may last seconds or over an hour, moving at speeds up to 70 miles per hour. As it travels, it sucks in air, dust, and debris, often growing darker and wider. The tornado's journey is chaos, a dramatic chapter that began with a simple meeting of warm and cold air. Its life cycle is brief but unforgettable. The storm's fury is now fully realized. Tornadoes can occur almost anywhere, but some places see them far more often. The most famous is Tornado Alley in the central U.S., Texas, Oklahoma, Kansas, and Nebraska, where warm Gulf air meets cold Rocky Mountain air. Dixie Alley in the southeast is another hotspot, with tornadoes often hidden by rain and terrain, making them especially dangerous. The Bengal region, Bangladesh and eastern India, also faces deadly tornadoes, with volatile air masses and high population density. South America's tornado corridor and parts of Australia experience their own tornado activity. While less frequent elsewhere, tornadoes are a global phenomenon. The laws of atmospheric physics know no borders. Wherever the right ingredients meet, tornadoes can form. The power of a tornado is staggering. Scientists use the enhanced Fujita scale, rating tornadoes from EF0 to EF5, and EF0 may break branches and damage roofs, minor but still dangerous. EF2 and EF3 tornadoes can tear roofs off houses, overturn trains, and lift cars. The destruction is serious. Lives and property are at risk. At the top, EF5 tornadoes are rare monsters, with winds over 200 miles per hour. They can sweep away entire houses, strip bark from trees, and hurl cars for miles. Even small objects become deadly projectiles. A straw can pierce a tree, a plank can spear a car door. The combination of extreme wind and flying debris makes these storms so destructive. An EF5 tornado is nature's ultimate force, terrifying and awe-inspiring. The aftermath is often total devastation. Tornadoes remind us of the raw power hidden in our atmosphere. Their impact is unforgettable. Tornadoes are powerful, frightening, and fascinating. Once mysterious, we now study them to save lives. Understanding how tornadoes form, air masses, wind shear, supercells, helps meteorologists forecast them. Doppler radar can spot rotation inside storms, giving precious minutes of warning. These warnings mean the difference between safety and disaster. Storm chasers and researchers gather data, refining our models and improving our defenses. This research leads to stronger buildings and better warning systems. By learning about tornadoes, we learn to coexist with nature's fury. Watching the skies, we turn fear into knowledge and respect. With vigilance and science, we can protect ourselves and our communities.